Ladies and gentlemen, let us solve this exponential function. It says integrate exponential raised to x all over 1 plus exponential raised to x dx. Now, let us have a look at the solution on how we can solve this question. Now, this is an exponential function, and we can solve it using the u substitution. And in this case, we can say that let u be 1 plus exponential raised to x. That is 1 plus exponential raised to x. Now, if I differentiate u with respect to x, then I will have, if I differentiate a constant, it is 0. And if I differentiate an exponential raised to x, it is just exponential raised to x. Now, looking at our question, we have exponential raised to x dx. And therefore, in this case, I can make the u the subject so that I have du equals to exponential raised to x dx. Because I have to multiply by dx on both sides. That is by dx on both sides, so that this one and this one cancels. And therefore, du equals to exponential raised to x dx. Now, reaching at this point, we had let this one to be u. Therefore, this one will be exponential raised to x dx all over u. And in that case, we shall have, that is the integral of exponential raised to x, then dx all over u. Now, because we had let, that is 1 plus exponential raised to x to be u. And also, exponential raised to x dx is our du. And therefore, this one will be the integral of, that is, instead of exponential raised to x dx, then we shall have du all over u. Now, at this point, if you integrate du over u, we shall have, that is, ln of u, then plus the constant of integration. But what is our u? Our u is 1 plus exponential raised to x, and therefore we shall have ln of 1 plus exponential raised to x, then close the bracket, plus the constant of integration. And that is the answer that we shall obtain in integrating this exponential function.